Chapters 3.3 and 3.4 are basically a continuation of 3.2 with greater difficulty. Again, I just want to go back over my 5 steps of solving equations. If you can, simplify either or both sides of equals by doing what it says. If there's an x on both sides of equals, small x to big X by either adding or subtracting, because you take the x with it. Then eliminate whatever's added or subtracted to the x, again by doing the opposite. Eliminate whatever's multiplied or divided to the x by doing the opposite. Remember to take the sign with it. If you check the problem, you do this by putting the solution into the original problem. Why not put it in an intermediate step? Because you might have made a mistake in an intermediate step. Now, there is a little sneak when you've got a fraction with a number on the bottom and you've got one or two terms over here. A whole number is considered a fraction over 1, and now we can use the shortcut of cross multiplication. So 1 times stuff is stuff, so 2 times a plus 3, and then 3 times other stuff, so 3 times 6a plus 2. Now when there's an equal sign, it doesn't matter which problem goes on which side. However, when there's a inequality, a less than or a greater than sign, remember you must go from bottom right to top left first, and that has to go on this side, and then bottom left to top right has to go on the right side. Not a big deal when there's an equals, but it gets the problem wrong if there's an inequality there. 2 times a is 2a, and 2 times 3 is plus 6. 3 times 6a is 18a, and 3 times 2 is plus 6. Now, next step says, if x is on both sides of equals, small x to big X. If you do not do this, if you don't do this first before getting rid of a number, this problem can give you some serious headaches and you won't know what to do with it. And you'll understand in just a moment why. So 2a minus 2a leaves 6 equals, and 18a minus 2a leaves 16a plus 6. Now, I don't want to move this one. I want to move this because this is added to a. The opposite is to subtract it. And that gives us 16a equals, 0. Now if you would have gotten the 6's going away and you'd have had a 2a equals an 18a, that would have been really, really confusing. So seriously, pay attention to what I'm saying. You've got to get your a's together first, and you've got to do it with small a to big A. Then we divide by 16, and I'm going to come up here, and a equals 0, because 0 divided by any number is 0. But remember, if 0 is under, it's undefined. Now, there is a nice little shortcut here. If I take 0.25 times 10, that gives me 2.5. But if I take 0.25 times 100, that gives me a whole 25. 1 0, I move the decimal place 1 time. 2 zeros, I move the decimal place 2 times. Well, guess what? All of these have 2 decimal places. So technically I am multiplying every problem or every term here by 100, and we've got 1, 2, 3 terms. So 0.25 times 100 leaves us 25, and then x, plus 0.10 times 100 is 10, and we don't touch the x minus 30. And then 1.10 times 100 leaves us 110. Now we distribute. So 25x's plus 10x's minus 30 equals 110. Now I'm going to do two things at one time. I'm going to combine those, and I'm going to add 30 to both sides. So 25 plus 10 is 35 x's equal 140. Now, since you are in chapter 3, I'm going to cheat a little bit because we're allowed to use the calculator at this point. So I'm going to turn it on, and I'm just one more second. 35 is multiplied to x, so the opposite of multiplying is to divide, and x equals, now on my calculator I'm going to take 140 divide by 35, and that gives me 4. And again, when there's a lot of work, if you're having to write it out, which you will have to do starting at least in 150 or 110, whichever class, it's best to box in your answer. Something unexpected happens with the next two examples, okay? So pay attention. Now I'm going to distribute on both sides. So it gives me negative 2x plus 10 equals negative 3x minus 6, because minus times a positive, and then plus 1x. I don't very often put that plus 1 in front of the x here. Now combine our like terms. Now negative 2x plus 20 equals, negative 3 plus 1 is negative 2x, and then minus 6. Small x to big X. They're the same size. So they both go away. And that leaves us as 20 equals negative 6. What? Not in my day. And I promise, not in your day either. These are not alike. That's not true. So I'm going to say false. And when we get a false statement, this is no solution. Yahoo! Now, let's look at this one. I'm going to distribute my 3. So that's 3x minus 12. What? Equals 3x minus 12? When we get something that's exactly alike, they are the same, then this is every, whoops, not x, every solution, or all real answers. Because these are the exact same line. Okay, I'm going to show you how to set these up. A lot of times at this point now they're going to ask you to find that number. Okay, so I'm just going to set them up and I'm going to let you solve them. 20 increased by a number. 20, and then increased means plus, a number means x, is means equals, and then 5. And I'm going to let you solve that. Now, twice a number means 2x, equals means equals, and then negative 10. A number minus 11. A number is x, minus is minus, 11, amounts to means equals, 168. Number D. 3 times the sum. Remember, that's a big fat hairy deal. 3 times the sum. Okay? The sum of a number and 5. So it means x plus 5 is, again, means equals, and then your negative 30. The quotient of twice a number and. Remember, quotient is divide, where the and sign is where the divide sign goes. Now, twice a number means 2x, and then we put our 8 is equal to 2. Twice the sum. Twice the sum means 2 parentheses. Okay? Sum of a number and 3, so a number plus 3, close it up, is equal to 3 times the difference, so 3 parentheses, difference of a number and 7, so x plus 7. Notice when it says twice a number, it means 2x. But when it says twice the sum, that's 2 parentheses. Okay, keep those straight. They are not going away.